it's not that like we're going to take a test and I want you to do like awesome at the test or something. But you guys see me now?
Yeah.
Yeah.
Awesome. Okay, so some of these problems involve like a number of things that we've done throughout the year. So it's been like balancing equations. That's kind of one of the last things that we did before our regular school year kind of stopped. Some things with like moles and mass. That's probably where you probably had some trouble with doing some of those problems. So, like I said, if you're doing those, I don't want you to get so frustrated like, oh my gosh, I've got a test next week I've got to get 100% on. But I do want you to understand it because it's important to chemistry. And so don't freak out if you miss some of those questions on those practice problems. So I'm going to go over maybe 3 or 4 of these problems. And if you have it at home, if not, that's no big deal. But you may want to get out like your periodic table, if you have it, or even a calculator, something to write with. I'm recording this right now too, so hopefully I'll put this up on Google Classroom so you'll be able to see it as well. But one of the first problems that you probably had, it was called like mass to mole or mole to mass. And can you guys kind of see the board? Can you see the problem? Probably if you're on the phone or... Can you guys see this well enough?
Yes.
Awesome. Okay. So this particular problem, how many moles of NaCl, which is like table salt, result from the complete reaction of 241.4 grams of chlorine or Cl2? Assume there's more than enough sodium, so we really don't worry about that. And here's our balanced equation. Kind of tells us what's going on. So really what it says is, if you had 241.4 grams of the chlorine, how much, just in moles of NaCl, would you produce? So it's like if you put in this amount, how much of this are you going to get out? It's like a basic chemistry problem. It's almost like a recipe. If I have this many, let's say, cups of sugar, how many cookies am I going to get out? That'd be oversimplifying it, but that's the idea of this. So the way we're going to go through this is we're going to use this balanced equation sort of as like our recipe, our guide to kind of solving it. And so what we want in the end is moles of NaCl. So question mark, moles. So the basic steps that we're going to go through is going to be, all right, we're going to take our grams of chlorine, convert that to moles of chlorine, and then we can take it times this molar ratio. So our first step is going to be taking this amount, 241.4 grams of chlorine. So chlorine's diatomic, it's Cl2. And we're going to change that to moles. So if you remember, this is way back, like first semester we had molar mass stuff. You find chlorine on the periodic table, and each chlorine is 35.5. But since I have 2 chlorines, it's Cl2, you just double that. And you get 71 grams. So again, this first step is just changing it from grams of chlorine to moles of chlorine. And I can cancel the grams of chlorine here. Then my next step is, all right, I want to see how many moles of the NaCl that would produce. So I have to look at, just erase this a little bit here, my mole ratio. So you look at these coefficients out in front. Well, there's nothing in front of the Cl2. That just means there's an understood 1 there, but there's a 2 here. So what that means is for every 1 mole of chlorine, you get 2 moles of salt. So it's a 1 to 2 ratio. And that's sort of my next step, which is the last step. So I put 1 mole of Cl2 on the bottom because it'll cancel this. And then my answer, what I want out in the end, 2 moles of NaCl. So my moles of Cl2 cancel. And now it just becomes a multiplication division problem. 241.4 times 1 times 2, and then you divide everything that's on the bottom denominator, which is just 71, and the answer you would get would be 6.8 moles. So 6.8 moles of NaCl. So when you're doing these problems, it's like, okay, what am I given in the problem first? Well, I'm given grams of chlorine, which is a reactant, what you start with. And then what am I trying to find out? Well, it's moles of NaCl. Well, that's a product over here. But in order to use this balanced equation, you have to convert the chlorine to moles first. So that's what this step is about. I take the grams of chlorine, and this step changes to moles. And then you apply the mole ratio. Like, what are you given? Well, there's an understood 1 here, and there's a 2 here, so that ratio is 2 to 1. And what you want out in the end goes on the top, goes on the numerator. So it does several things that we've done in the past, like changing from grams to moles, that's in there. We just got into balancing equations before we left. Any questions on this problem? Anything that's confusing?
So you doubled the moles on the chlorine? You doubled it because there's 2 of them?
Correct, yes.
Okay.
You're right. So yeah, chlorine is 35.5. So I double that because it's Cl2. Correct. Good question.
Okay.
All right, anybody else? All right, we'll go to a different, probably similar. It'll just be, so this one was, I give you a mass, and I want moles out in the end. It'll kind of be reversed, but some of the same type of things will be going on. So I'll erase this. So, and again, if you missed that and want to look at it, I am recording this, so okay, let's go to the next problem. So this problem, it says how many grams of H2O, of water, result from the reaction of 4 moles of O2. Assume there's more than enough H2, so it doesn't run out. So in this case, I want to know how many grams of H2O. So question mark grams of H2O. And I'm given moles of O2. So 4 moles of O2. So it's a little bit opposite of what we just did. We're still going to be using the balanced equation. But again, when you start this problem, what am I given in the problem? Okay, it's 4 moles of O2. And what am I trying to find? Well, it's grams of H2O. So to do this problem, we're going to go from moles of O2 to like moles of H2O. And then once we have moles of H2O, we can go to grams of H2O, is how that will kind of look. So the first step would be writing down what I have, 4 moles of O2. So my question is, how many moles of H2O would that produce? So I look at the equation. There's an understood 1 right here. So the ratio is 1 to 2. So I put my 1 on the denominator, cancels out this. For every 1 mole of O2, there's 2 moles of H2O. I can cancel my moles of O2. Well, if I were to stop right there, that would just tell me how many moles of H2O I would have. It would be 8, right? So 4 times 2 would be 8. But my question is, how many grams of H2O? So the last step would just be going from moles of H2O to grams. And we do that by finding the molar mass. So times, and 1 mole of H2O. Well, I look on my periodic table, I'd find hydrogen is 1, but I've got 2 of them. And oxygen is 16. Okay, so 16 plus 2 is 18. So 18 grams of H2O per mole. So if I had 1 mole of H2O, it'd be 18 grams. So just like the other problem, we multiply the numerator, divide by what's on the denominator. So 4 times 2 is 8. 8 times 18 happens to be 144. So that would make 144, drop my marker, 144 grams of H2O. So it's like you're given this amount of moles, amount of oxygen, and we're saying we're not going to run out of hydrogen, so we don't worry about that. How much H2O would that make? So you use your mole ratio, 2 to 1. That comes from 2 to 1 here. Are there questions on this problem here? So like on your assignment, on your CK12, those practice problems, that would be kind of that first one that says like mole to mass or mass to mole. We're kind of combined there. All right, no other questions? We'll kind of go over to the next section. So the next section was very similar. It just said like mass to mass. And it's just a little bit more like if you're doing this in a lab. Like in a lab, you don't go put something on the scale that gives you moles. It's going to give you mass, so it's a little bit more realistic. If you're doing a lab and you said, okay, I want to put in this much reactant, how much product am I going to get out? I would measure it before, I'd measure it afterwards, and compare.
So wait.
Okay, I'll
is
go.
This no, you can stay on the next one.
Okay, yeah.
I was just wondering if this is the section that you put on. I can't remember. This is the section you put on this week, or this is previous week's.
So that would be this week, yeah.
Okay.
Yep. Okay. So this particular equation, it says how many grams of hydrogen can be produced from 50 grams of magnesium. So it's asking how many grams, but it's giving you grams too. So we call it like the mass to mass. It's still using like an equation. So it's saying you have 50 grams of the magnesium, and it's saying how much hydrogen would that produce. And it says you have more than enough HCl, so you're not going to run out of this. So this particular reaction is like very, very similar to the ones we did at the deep reaction well. We actually did this reaction. You had that deep reaction well, I put the small pieces of metal in there, and we put the different acids in. But if we had 50 grams, how much hydrogen would that produce? That's sort of the question. So again, when you're doing these problems, what am I given and what am I trying to find? So the way we're going to do that is we're going to have to change grams to moles. The reason why we do that because that's how we apply this ratio. And we can already kind of see the ratio is going to be 2 to 1. There's an understood 1 here. That's a balanced equation. So step 1 is going to be taking the grams of magnesium, changing it to moles, because that's how I can apply the mole ratio. So I would take 50 grams of magnesium. Again, that's given in the problem. But I want to get to moles of H2O, but I can't directly go there. I have to change it to moles of magnesium first to compare. So for in 1 mole of magnesium, there's going to be, well, you look at your periodic table, and magnesium's 24.3. So 24.3 grams. So my grams of magnesium can cancel. And again, the reason I did that, now I can use the mole ratio. well, oops, I think I said 2 to 1 earlier, sorry. It's 1 to 1. We're not dealing with this. So it's 1 to 1. There's a 1 here, and an understood 1 there, coefficient-wise. So even though mathematically you don't have to write it, I'm going to write it. And so it cancels. 1 mole of magnesium for every 1 mole of H2. So I cancel out the moles of magnesium. So if I stopped right here, I'd be in moles of hydrogen. But the question is, how many grams of hydrogen? So the last step would just be converting moles of hydrogen to grams of hydrogen. So in 1 mole of H2, so we know hydrogen's just 1, but there's 2 hydrogen for every 1 molecule. So 2 grams. So my moles of hydrogen can cancel. And it becomes that multiplication problem again. 50 times 1 times 1 times 2, and then divide what's on the denominator, which is just 24.3. In that case, you get 4.12 grams of hydrogen. So this problem, similar to the last two, except you kind of have one more step because I'm given grams and I want to go to grams. But in between, you kind of have to do this mole thing where you have to convert to moles, do the mole ratio, and then take it back to grams. But you always have to keep in mind, what am I starting with and where am I going? And so this problem, like I said, it's very similar to even like when we blew up that hydrogen balloon on one of those last days we had class. I used zinc and hydrochloric acid, but anyways. Any questions on that?
So the 2 grams of hydrogen on the end,
Yes.
that comes from it. That comes from what again?
So that comes from hydrogen is 1 gram per mole. So for the periodic table, but it's H2, not just H. So
Okay.
I want to know what the mass of 1 mole of H2 is. And hydrogen's 1, but since I have 2 of them, H2, it's 2 grams. So, all right, good question. Any others here? All right, we're going to have kind of one more problem. And sort of the last section on this week on that, like the CK12, was this limiting reactant part. So a limiting reactant, if you're having a reaction, it's like, what are you going to run out first? So the analogy that I sometimes would give would be, let's say you're making peanut butter and jelly sandwiches, and you have 50 pieces of bread, and you have like 5 jars of peanut butter, but you only have like a half a jar of jelly. And you start making peanut butter and jelly sandwiches, and of course, you've got enough bread, you've got enough peanut butter, but you're going to run out of jelly first. So the amount of jelly determines how many sandwiches you can make. Well, with chemical reactions, how much you get out in the end, the product is related to this limiting reactant. What do you have least of? And that's kind of what this is going to be about. And so, again, let me erase this a little bit better. So this particular example, it's a limiting reactant. So you're thinking of like what runs out first. What is a limiting reactant and theoretical yield? That's like in theory how much you should get of this aluminum chloride when 0.552 moles of aluminum react with 0.887 moles of chlorine. So my kind of question is it going to be the aluminum that runs out first, or is it going to be the chlorine that runs out first? And then the amount of aluminum chloride that is produced, you take whichever makes the smallest amount, and that's going to be your theoretical yield, like in theory how much it should make. So again, that's sort of that last section, that there's a limiting reactant section on CK12. So if you're doing those problems, again, some of those practice problems might get a little more challenging. Don't get stressed out that you get all of them right. I just want you to be familiar with this stuff, be exposed to this stuff. But anyways, the idea of this problem is I'm going to take, let's say, aluminum and see how much aluminum chloride it can make. And then I'm going to take the chlorine and see how much aluminum chloride it can make. And then whichever one is smaller, that's going to be the one that's the limiting reactant. So I'm going to start with the aluminum first, which is 0.552 moles. And you could do this with grams. If they gave you grams, you'd have to just convert it right to moles right away. So I'm going to take my moles of aluminum and say, okay, how many moles of aluminum chloride could that produce? And the math is going to be pretty easy because the ratio here is going to be 2 to 2. But just to show you how this would work out, because you do have some other problems, it's not going to be 2 to 2. So 2 moles of aluminum, 2 moles of aluminum chloride. And of course, we're going to get the same number, 0.552, but now it's moles of aluminum chloride. So what that is saying is if you have 0.552 moles of aluminum, it would actually make 0.552 moles of aluminum chloride because the ratio is 2 to 2, which is like 1 to 1 if you were to reduce. So. But let's see how much aluminum chloride can be made if I have this much chlorine, because that's the other reactant. It's not 2 to 2. So 0.887 moles of chlorine. Well, the ratio here is 3 to 2. My 3 goes on the bottom, so it cancels out the chlorine on the top. My 2 goes on top. And you multiply times that ratio. 0.887 times 2 divided by 3, and you get 0.591. So what you do at this point, which one is going to be smaller? Well, this is the smaller amount that's made. So what that tells me is the aluminum is the limiting factor. Whichever made the smaller amount, that's going to be the limiting factor, or the limiting reactant. So we'd say the limiting reactant is aluminum because it made the smaller amount. Now my theoretical yield is just that amount. In theory, if you had these two things, this amount of aluminum and this amount of chlorine, in theory it should make this amount. That's the smaller amount. And so that is equal to, you say, theoretical yield. That's just what we call that amount. If we did this in the lab, that would be called the actual amount, because we do it in the lab and stuff would get lost or some powder would go down the drain or up in smoke or something. But in theory, this is how much should be made. But that's the idea of limiting reactant. You have 2 or more reactants. You take their amounts, see how much they can make individually, and whichever makes the smallest amount, that substance that made it is your limiting reactant. Sort of like the weakest link in that. Or if my analogy with the peanut butter jelly sandwiches, it was the half jar of jelly that you had, that you would run out first. So, but that's the idea with that. I would say that if you're doing some of these problems on those practice ones on CK12, and you get to the ones that have like volume, like liters. Morgan, are you on here? Morgan Simpson, I think.
I am.
Okay. Yeah, I think that was a little bit harder problem, that the ones that have to do with volume, because you kind of have to know about that 22.4 liters. I wouldn't get too worried about that. The ones that deal with moles and mass, those would be the ones that I'd be want you to kind of know.
I think my issue was that I did the lessons in the wrong order.
Oh, okay.
So that probably wasn't helpful at all.
Oh, so you probably did the limiting reactant stuff first?
Yeah.
Oh, that would be really confusing, yeah.
Yeah, Yeah.
I probably should have put something on there. I probably should have put something on there like, yeah, do the mass stuff first and whatnot. So, anyways, any questions on any of this? These are the problems I wanted to go over. It gives you an idea of what we were doing. I wish you guys I could be in the same classroom as you and actually do some of these labs that we'd be able to do, but let's just make the best of it. So, any other questions? Like people that may have looked at this and had any particular, and you can still, after you've looked at it, you can leave me a message, and I can work out the problem and take a picture of it and send it to you. I can certainly do that. So if you get to a specific practice problem, like I have no idea what Morgan did, she took a screenshot and then sent that to me. That works, or you can just tell me what your problem is. So, all right. Well, there will be, if there's something you want to kind of look back at, some of my work or something, there will be a video up on Google Classroom here in the next 30 minutes or so. We'll get that up. It'll be a link to a YouTube video. So, all right. If no other questions, probably shut it down. So, again, we may.
What?
Go ahead. Yeah.
What's the order for the assignments?
So the order of the
In the
assignment.
classroom?
Yeah. So the order. Let me actually bring that up here. If I think do that. Okay, so erase this. So yeah, the order that you'd probably make the most sense is, it would be mass to stoichiometry, mass to mole, and then mass to mass, limiting reactant, and then determining limiting reactant. So mass to mole, mass to mass, limiting reactant, and determining the limiting reactant. So that would be kind of the order you want to go in. Next week is not going to be as quantitative. I knew this was the one chapter that was going to be pretty tough without being in the classroom. But any other questions? All right, everybody hang in there. Sure, everybody's doing fine. Just do your best. Get out of it as much as you can get out of it, and I'm going to be happy with that. You can email me, message me if you have any individual questions. So we'll see y'all later.